Dr. Catherine from ChemPraxis. Today, I'm going to discuss February-March 2024 paper for 9701 A-level chemistry. For the first questions, bismuth is an element in group 15 of the periodic table. Bismuth has metallic bonding. Draw a label diagram to show the metallic bonding in bismuth. So, for this question, it's pretty simple. We just need to draw the diagram for metallic bond in which we need to show that there is a positive metal ions in the layer form, at least 3 layers, and then we have the sea of delocalized electrons. You will get 1 mark for this diagram. For the next question, bismuth reduce water to form bismuth oxide, Bi2O3, a colorless gas that ignite with a squeaky pop also form. So if let's say there's a colorless gas form that with a squeaky pop sound, it is the hydrogen gas. So in order to construct an equation for the reduction of water by bismuth, you can refer to this equation. And also with the correct balancing, you can get another 1 mark. For the next question, Bi2O3 is a yellow insoluble solid that melts at 1090 Kelvin. The molten compound conduct electricity. Deduce the structure and bonding of Bi2O3. Explain your answer. If let's say the molten compound can conduct electricity, usually only ionic compound can conduct electricity in molten or aqueous state because they have the free moving ions. And also, for this melting point, 1090 Kelvin is pretty high. Usually, strong ionic bond, you need a lot of energy to break the strong ionic bond, so they have high melting point. So for the structure and bonding, first of all, you need to highlight that this is a giant ionic lattice. And then for the bonding, it is ionic bond due to the high melting point. And also another explanation, they can conduct electricity when molten state, means that they have free moving ions. For the next question, Bi2O3 can be used to form NaBiO3 as shown in equation 1. Deduce the oxidation number of Bi in Bi2O3 and in NaBiO3. Oxidation number of Bi. For this question, it's pretty simple because for Bi2O3, basically the charge is positive 3. While for NaBiO3, we need to work out the calculation. For example, for Na, it is positive 1. For Bi, we need to find the oxidation number. For oxygen, it is 3 times negative 2. And the whole molecule is neutral, so it equals to 0. And from these calculations, we will be able to find the oxidation state for Bi. Identify the reducing agent in equation 1. So for reducing agent, they go through oxidation. Since the oxidation number of Bi increase from positive 3 to positive 5, so the reducing agent is the Bi2O3, but in particular is the Bi itself. For the next question, NaBiO3 is an oxidizing agent with similar properties to KMnO4. Figure 1.1 shows an example of the use of NaBiO3 as an oxidizing agent. So for the first question, explain the term oxidizing agent. So for oxidizing agent, basically they go through reduction, but in this case, we need to highlight the definitions for oxidizing agent. So for agent, it is a substance. And then for oxidizing means that they cause electron loss or they remove electron from another. And for the second question, compound X forms when methylbutene react with KMnO4. So for compound X, it is a diol. And in order to change alkene to diol, we need to have a co-dilute acidified KMnO4. For the third questions, complete table 1.1 to show what is observed when compound Y and Z react separately with the named reagent. Compound Y is a ketone, while for compound Z, it is an aldehyde. So, for the first reagent, it is sodium carbonate. Usually for sodium carbonate, we use it to test carboxylic acid. So in this case, since both of them are not carboxylic acid, they have no reactions. And for the next one, it is alkaline iodine, and this is the iodoform test. Usually, we want to test if there is any CH3 next to C double bond O. And since both of them have CH3 next to C double bond O, they are forming yellow precipitate. And for the third one, we have 2,4-DMPH. 2,4-DMPH, we usually use it to detect the presence of carbonyl group, and since aldehyde and ketone are both carbonyl, they will give you the orange precipitate. Last but not least, we have Tollens reagent. For Tollens reagent, we use it to test the presence of aldehyde. So for ketone, there is no reaction, but for aldehyde, we have silver mirror. For question 4, we need to construct an equations for the reactions of Z with NaBH4. So NaBH4 is a reducing agent. And for this reducing agent means that they will provide hydrogen to the organic compound. So for example, if I have an aldehyde, so this aldehyde will receive the hydrogen from the reducing agent, and they will change from aldehyde into primary alcohol. So for this structure, this is the structure of primary alcohol. And in terms of the molecular formula or structural formula, both of them are accepted for this answer. For the next question, NaBiO3 can be used to determine the concentration of MM2+. The ionic equation for the reaction is shown in equation 2. A student used the following procedure in an experiment. Add 100 cm³ of a saturated solution of MM2+ to a volumetric flask. Add distilled water to the flask to make a 1 dm³ dilute solution. Titrate a 25 cm³ sample of the diluted solution with 0.1 mole per dm³ of NaBiO3. So the 25 cm³ sample of the diluted solution of MM2+ react completely with exactly 21.5 cm³ of 0.1 mole per dm³ of NaBiO3. Calculate the concentration in mole per dm³ of MM2+ in the saturated solution. Show your working. For the first step, we need to calculate the number of mole of NaBiO3 by using the volume and also the concentration. We divide 1000 because we are trying to change the cm³ to dm³. So this is the number of mole of NaBiO3. For the next step, we need to find the number of mole of this Mn2+. Because according to the ionic equation, the mole ratio for this equation is 5:2. Basically, we can use the mole ratio 5. In the ratio of 5, we have 0.00215. So in the ratio of 2, we have 0.00086. After that, this 0.00086 is in 25 cm³. And because this 25 cm³ is originated from the 1 dm³ diluted solution, we need to find the number of mole when it is in 1 dm³ or 1000 cm³ solution. So after the calculations, we get the answer equals to 0.0344. And this is not the last step because we still need to find the concentration in the saturated solution. We find the number of mole equals to 0.0344 and the volume for saturated solution is 100 cm³. So we need to divide 0.1. We change the 100 cm³ to dm³ to find the concentration, and this is your final answer. So for question 2, chlorine react with many elements and compounds to form chlorides. Table 2.1 shows information about some chlorides of period 3 element. For table 2.1, first of all, they ask you the formula of chloride. So for formula of chloride, Na is NaCl, Mg is MgCl2, Si is SiCl4. For the structure of chloride, because for NaCl, it is ionic bond, so for the structure, it is giant ionic lattice. So we need to put giant here. And for magnesium chloride, it is an ionic compound as well, so also giant ionic lattice. And for SiCl4, it is a simple molecular structure, so we put the word simples here. And for the pH of the solution, because NaCl is a neutral salt, so the pH is 7. While for Si, because when SiCl4 dissolve in water, they will form SiO2 and HCl. And HCl is a very acidic or strong acid. So in this case, the pH need to be 1 to 4. We can accept this. But of course, if you write 1 or 2, because of HCl, you're not wrong. For the next question, when chlorine react with co-NaOH, Cl2 is both oxidized and reduced. The products are NaCl and G. State the type of redox reaction in which the same species is both oxidized and reduced. We call this as disproportionation. And for identity of G, it is NaClO, because when Cl2 react with co-NaOH, they will produce NaCl and NaClO. While for the next one, write an equations for the reaction between chlorine and hot NaOH. When chlorine react with hot NaOH, they will form NaCl, NaClO3, and also H2O. And you need to have the correct balancing in order to get the 1 mark. For question 4, describe fully what is observed when silver nitrate is added to the aqueous solution of the chloride of sodium followed by dilute ammonia. So if let's say silver nitrate is added to aqueous solution of chloride of sodium, they will give you the white precipitate because silver chloride is formed. And silver chloride can dissolve in dilute aqueous ammonia. So you need to highlight this as well in order to get the 2 marks. An excess of chlorine react with phosphorus to form PCl5. So PCl5 is a simple molecule in the gas phase. It also exists in a solid form as 2 ions, PCl4 positive charge and PCl6 negative 1 charge. So complete table 2.2 to identify the shades of each of these species. For PCl5, the structure, it looks like this. So this is the triangle, the trigonal structure, and they have one Cl here and the other Cl is here. So for this structure, it is trigonal bipyramidal. And for PCl6, if you draw the structure, PCl6 basically they have 6 Cl attached to the phosphorus. So for these, it is octahedral. And for the next one, PCl5 react with J to form H3PO4. So when PCl5 react with water, they will form H3PO4. And because water break the bond between phosphorus and chlorine, we call this as a hydrolysis process. For question D, chlorine react readily with propane to form K, 1,2-dichloropropane. K can be used to form L. Complete figure 2.2 to show the mechanism of the reactions for Cl2 with propane in reaction 1. Include charges, dipole, lone pair of electrons, and curly arrow as appropriate. So for the first arrow, you need to show me that the arrow from the double bond to the Cl. And you need to label Cl as partial positive because the electrons in the double bond, they repels the electrons in chlorine. So because the chlorine is away, the electron is away from this chlorine, this one become a partial positive. And for the next one, you need to draw the second arrow from the covalent bond to this chlorine. And this chlorine will become a chloride ion with lone pair of electrons. And because the electrons in the double bond is used to form bond with the Cl, this carbon now is a carbocation, and it is a secondary carbocation. And then the Cl minus ion, they will use the bond, the lone pair of electrons to form bonds with this carbocation to form the final products. For the Roman 2 questions, they say identify the reagent and condition for reaction 2. So this is reaction 2, and this is the reactant, and this is the product. So before that, we have a Cl on the first carbon, but after that, they become a double bond. So this process is elimination process. Eliminations of HCl. In order to eliminate HCl, we need to have NaOH in ethanol solvent, and we need the heat. And the next question, draw one repeat unit of the addition polymer that forms from L. This is L, and this is an addition polymerization. So we just need to break the double bond, and then we extend it, and this is the polymer structure for L. Okay, now we are going to discuss question 3. So for question 3, nitrogen is generally an unreactive molecule, but it does react under certain conditions. Give 2 reasons to explain the lack of reactivity of nitrogen. So usually for nitrogens, they have a strong triple bond, which is very hard to break, and they are non-polar. So if let's say there are any polar reagents that trying to approach nitrogen, there's no reactions. For the next question, nitrogen can react with oxygens in an internal combustion engine to form a mixture of NO and NO2. Figure 3.1 shows a reaction scheme involving N2. For the reaction 1, N2 react with oxygen to form NO and NO2. In order to write an equation to show the formation of a mixture of NO and NO2 in reaction 1, we can write this equation. And for your information, fraction is allowed in your mark scheme. And the next one, the reaction 2, NO2 react with H2O to form the products. So when NO2 react with H2O, since NO2 is an acidic gas, they will form acid rain. And the acids will be HNO2 and HNO3. And for the third reactions, when NO2 react with unburnt hydrocarbon, they will form peroxyacetyl nitrate. And this peroxyacetyl nitrate is the photochemical smoke. For question C, the Haber process involves the reactions of nitrogen and hydrogen to form ammonia. A catalyst is used which allowed the process to be carried out at a lower temperature and pressure. Use the information in C to complete table 3.1. So they want to know the enthalpy change of formations for nitrogen, hydrogens, and ammonia. For enthalpy change of formation, if let's say it is an element, then the value will be 0. Same goes to the hydrogen. This one will be 0 as well. And in order to find ammonia, basically we can use this formula. The enthalpy change is equals to the enthalpy change of formations of product minus the enthalpy change of formations of reactant. So we put the negative 92. And also, we have the product 2 times enthalpy change of formations of ammonia minus 0. Because both of them are element, both of them are 0, so we substitute 0. Then, in order to find the enthalpy change of formations of ammonia, we can use negative 92 over 2, and we get negative 46. The next 2 question is pretty simple. Explain how the presence of a catalyst affect the reaction. They will increase the rate by providing an alternative route or a different mechanism with a lower activation energy and increase the rate of successful collision. And the third one, state and explain the effect, if any, on the rate of the Haber process as the pressure is lower. So if let's say the pressure is lower, the rate is lower because we have lower frequency of successful collision. For question D, the N2F2 molecule has a double covalent bond between its nitrogen atom. This consists of a sigma and a pi bond, means that it is a double bond. So complete figure 3.2 to show the dot and cross diagram for N2F2. Show outer electrons only. First of all, this is the double bond, and then this is the single bond. And N forms single bond with fluorine, and this one as well. And you need to make sure that you draw the non-bonding pair or the lone pair for fluorine and also for nitrogen in order to get the 2 marks. And deduce the hybridizations of nitrogen atom in N2F2, it is sp2. For any elements, as long as they have the double bond, then they are sp2 hybridizations. For the last part of question 3, we need to draw a diagram of the pi bond between the nitrogen atom in N2F2 and describe how it's formed. So, in order to draw pi bond, for example, this is the nucleus of nitrogen. and this is also the nucleus of nitrogen. But you don't need to label this in your exam. And the next thing, you need to draw the orbitals overlap on top of the nucleus and bottom of the nucleus, so that you show that for pi bond, it is a sideway overlap of p orbitals. So now we are going to discuss question 4. So for question 4, compound S is used in food flavoring. A possible synthesis of S is shown in figure 4.1. So this is P, is an alkene, react with HBr to form Q. And then after that, we have KCN in ethanol. And also we have the H plus ion. So for the first one, when they react with HBr, this is the structure of Q. And then when they react with Cn, the Br will substituted by Cn. And then for H plus, this is acid hydrolysis. They will change the Cn to COOH. So in terms of geometrical isomerism and optical isomerism, for P, they have geometrical isomerism because the CC double bond is attached to two different groups, so they can form cis or trans structure. While for Q, because they doesn't have the double bond, so they do not have the geometrical isomerism. Same goes to R and S. For optical isomers, you need to have chiral carbon. So for the first one, they doesn't have chiral carbon, but for the second one, we have the chiral carbons here. And then for the third one, this is the chiral carbon, and this is the chiral carbon as well. So for QRS, all of them have optical isomerism. For the structural I formula of Q, so you have this Br attached to the second carbon. We have CH3, CHBr, CH2, and CH3. And for the mechanism, in reaction 2, it is nucleophilic substitution. While to complete the equation for reaction 3, R is represented as C4H9Cn. So first of all, when you react with water, you will form C4H9CO and H2. And then after that, you react with another water. This time you will form C4H9COO minus and NH4 plus. And lastly, when you react with hydrogen ion in particular, you will form C4H9COOH. For the next question, compound S and T react to form organic compound U, which has a single functional group. So this is M plus, this is M plus 1. We can find the number of carbon atoms by using this formula, 100 divided by 1.1 times M plus 1 over M. So the M plus 1 is 0.55, and then the M plus is 7.2. So with this, we can find the number of carbon atom, which is 7. And for figure 4.2, they shows the infrared spectrum of U, and the one that I highlight is actually the one that we observe a peak. We need to observe the wave number. Same goes to this. And then after that, we need to refer to the infrared table in order to determine what is the bond that they are trying to represent. So from the graph, actually we can find that the functional group is ester, because they have an absorptions at 1040 to 1300 cm -1, indicates a C-O bond, which is this. And then they also have an absorptions at 1710 to 1750, which indicates a C double bond O, which is here. From the previous calculation, we actually know that the compound, the ester itself, they contain 7 carbon atoms. So after we know that it is an ester, and then we are trying to find what is the structure of U, basically this is the carboxylic acid. And then in order to make into a 7 carbon, we can propose that this is an ethanol. And when you have a carboxylic acid react with ethanol, they can form ester. So this is the structure of T. And when these go through condensation reaction, they will form ester, and this ester will be the structure of U. And this is the end of this paper. I hope you enjoyed this video. Please click the like and subscribe button for more past year paper explanations.